The current Midtown Tunnel between Norfolk and Portsmouth, Virginia, is one of the most heavily traveled two-lane highways in the Commonwealth. The proposed second Midtown Tunnel will increase capacity, reduce congestion, and provide safe and efficient operations for years to come. The construction team is comprised of a joint venture between Skanska USA Civil, Kiewit Construction Company, and Weeks Marine. They will be supported by a design team of Parsons Brinckerhoff, Volkert and Associates, and Covey. A significant example of the team's previous collaborations is the world's widest underwater vehicular tunnel, the Fort McHenry Tunnel in Baltimore, constructed by Skanska and Kiewit and designed by Parsons Brinckerhoff. The project can be separated into 5 distinct areas of construction. The second Midtown Tunnel itself, which will be built using immersed tube tunnel methods, the Norfolk approach, the Portsmouth approach, and an extension of the Martin Luther King Expressway, which will provide a direct high-speed connection to I-264. And finally, rehabilitation of both downtown tunnels and the existing Midtown Tunnel. Although the majority of the immersed tunnels in the United States have been steel shell concrete tunnels, like the Fort McHenry and the existing Midtown and downtown tunnels, concrete tunnel elements are being proposed both for their cost savings and flexibility of design. Tunnel fabrication will involve the construction of 12 rectangular reinforced concrete tunnel elements with temporary steel bulkheads installed on each end so the tunnel elements will float. It is planned that the elements will be fabricated in a local dry dock facility using in-house resources, local workforces, and the area's material suppliers, all of which the design-build team is very familiar. The fabricated tunnel elements are then towed to the job site. Installation of the immersed tunnel elements will require dredging a trench using a dredging barge and crane with clamshell bucket. The trench will be approximately 55 feet wide at the bottom and filled with a minimum of 2 feet of gravel that will be leveled to the proper grade using a screed barge. Placing the tunnel elements will be performed using a special catamaran barge with placing girders spanning the opening between the barge hulls. This placing barge is capable of receiving, supporting, ballasting, and lowering the negatively buoyant elements. To achieve negative buoyancy, a pair of water ballast tanks will be installed in each tunnel element. Removable survey towers, mounted on the outboard end of each element, combined with global positioning system technology, will be used to control the horizontal and vertical placement of each element during installation. Each tunnel element being placed has a thick rubber seal attached to its inboard end. It is compressed against a steel plate on the outboard end of the receiving element, and when water is pumped out of the joint chamber between the steel bulkheads, it creates a watertight seal between the new and previously placed element. The conceptual approach for the placement sequence is to install the 2 easternmost tunnel elements first so that the Norfolk approach work can proceed. Placement will then continue with the westernmost element so the Portsmouth approach work can also proceed. Tunnel element placement will then proceed eastward and connect up with the first 2 tunnel elements. This sequence provides the most schedule flexibility and has the added benefit of removing the final closure joint from the proximity of the shipping channel. Backfill of the installed immersed tunnel requires 3 distinct operations. First, a locking backfill to prevent any horizontal movement of the tunnel elements. The tunnel elements are then covered with ordinary backfill designed to bring the excavated trench back to an elevation that provides a protective cover over the tunnel. The final layer of backfill will consist of 12-inch armor stone to protect the tunnel from scour and from dragging ship anchors or other possible marine impacts. The tunnel elements will have at least 5 feet of backfill and protective cover, and all backfill operations will be accomplished using cranes with clamshell buckets. The tunnel interior will largely be determined by the required traffic clearances, requirements for ventilation, fire protection, and evacuation. A longitudinal ventilation system based on jet fans will result in the smallest cross-section while having the added benefit of the lowest future maintenance costs. Precast tile panels will face the lower 16 feet of the tunnel walls, with fireproofing mounted directly to the tunnel upper walls and ceiling. The design calls for a 3-foot 8-inch wide egress corridor accessible from the main tunnel by fire-rated doors spaced 300 feet apart. The Norfolk Approach roadway connects directly with the existing westbound lanes, thereby minimizing work within the existing interchange. The vertical alignment required to meet the Norfolk Approach will necessitate an expansion of the current peninsula by installing some earth fill in the river. The access road to the existing tunnel vent building will need to be permanently relocated. The Portsmouth Approach roadway yields a simple curve that fits within the existing right-of-way. The Port Access Road will have to be relocated permanently, and other temporary relocations of roads and railways will be required during construction, particularly within the port property. The relocation of the access roads and other approach roadway work will result in some minimal right-of-way impacts in Norfolk and Portsmouth. The Martin Luther King Expressway extension and interchange will provide a direct freeway-to-freeway connection between I-264 and the Midtown tunnels. The Elizabeth River Crossings project and its 5 distinct areas of construction, the Immersed Tunnel, the Norfolk Approach, the Portsmouth Approach, the extension of the Martin Luther King Expressway, and the rehabilitation of the downtown tunnels and the existing Midtown tunnel represent a smart growth investment, an investment in safe traffic operations, preventative maintenance, and rehabilitation that will keep the area's roads and tunnels running smoothly and preserve both the quality of the assets and the quality of service provided to the traveling public.